Okay, so today's lesson, what we're going to be talking about is conditional probability. Now, conditional probability, okay, so let me write that right here. Conditional probability is the probability of an event A given that another event B has already occurred. So given is going to be our key word here for us to know. If we ever see the word given, we know, oh, we're talking about conditional probability. So the formula that we're going to be using is this one right here. So A, this little vertical line means given. So A given B is equal to probability of A intersect B divided by the probability of B. So an example here is the probability that it is Friday and that a student is absent is 0.03. Since there are 5 school days in a week, the probability that it is Friday is 0.2. What is the probability that a student is absent given that today is Friday? So we've got a couple things here and we've got a couple keywords. Probability that it is Friday and that a student is absent is 0.03. Since this is and, we know that this is going to be our intersect. So probability of A intersect B is 0.03. Since there are 5 school days in a week, the probability that it is Friday is 0.02. Well, since our given statement is probability that a student is absent given Friday, that a student is absent is going to be our A, and it is Friday is B. So the probability that a student is, the probability that it is Friday is 0.2. This is our B right here, okay? So the probability of B is 0.2. So the probability that a student is absent given Friday, well, we've got the probability of Friday and absent, which is 0.03, divided by the probability of Friday, which is 0.2, equals 0.15 or 15%. Okay, so there's a couple things you want to be looking out for. First off, if you see the word given, you know it's conditional probability. And then you just want to decipher, if you have a word problem, you just want to decipher the info that it gives you. So Friday and absent, oh, that's going to be our A and B. The next one, probability that it's Friday, is 0.02, or excuse me, 0.2. That's probably going to be our B value, and then it's going to ask us for A given B. So we just plug it into this equation, and then we get our final answer. Okay. So a couple examples. At Denmark High School, the probability that a student takes technology and Spanish is 0.087. The probability that a student takes technology, just technology, is 0.68. What is the probability that a student takes Spanish given that a student is taking technology? So I've got our formula here. Anytime you see the word and, you know that is probability of A intersect B. So technology and Spanish is 0.087. So I'm going to have 0.087 on top. And then on bottom, it says what is the probability that a student takes technology is 68% or 0.68. And so we've got 0.087 divided by 0.68, which is going to give us about 0.128 or 12.8%. So our final answer is 12.8%. Another one, a math teacher gave her class 2 tests. 25% of the class passed both tests. So this is another way of saying 25% of the class passed both tests A and B. And 42% of the class passed the second test. What percent of those who passed the second test also passed the first test? So probability of A given B equals probability of A intersect B divided by probability of B. So we know that 25% of the class passed both test A and B. So our top value is going to be 0.25. And then probability of someone passing test B is 42%. So probability of B is 0.42. So the probability of passing A given B is going to be about this 0.25 divided by 0.42, which is 0.55 or 55%. Okay. Now, sometimes you might have two events that are independent of one another. If they are independent of one another, meaning they don't affect one another, say for example, flipping a coin. Flipping a coin the first time has no effect on flipping a coin the second time, right? Those are independent events. So if your events are independent, then the probability of A given B is just probability of A. So if we work out the formula here, probability of A intersect B, that is probability of A times probability of B if they're independent. And those just cancel out and we're left with probability of A. The same can be said for the probability of B given A. If you are trying to find probability of B given A and you know that these are two independent events, then this is just going to equal the probability of B. So just a couple examples here. Events A and B are independent, so we already know they're independent of one another. Find the missing probability. So probability of A is 1 over 4. Probability of B is 3 over 5. Find the probability of B given A. Well, since these are two independent events, I don't even have to worry about calculating this. I already know that it's going to be the same as probability of B. And so the answer is probability of B given A. It's the same thing as 3 over 5 because probability of B is also 3 over 5. This one right here, probability of B is 9 over 20. Probability of A given B is 1 over 5. Find the probability of A. Again, I know that probability of B and the probability of A are independent. So that must mean that probability of A given B is going to be the same as probability of just A, right? So if the probability of A given B is 1 over 5, then the probability of A also has to be 1 over 5. Okay? So what I want y'all to do is I want y'all to complete the following practice problems below, and on Wednesday and Thursday we'll have a concept check over this material that's going to be for a grade.